So in our very first day, we discussed about was your 5 phases of ethical hacking, in which we discussed about reconnaissance, the very first phase, scanning, gaining the access, maintaining the access, and covering the tracks. So in this, we covered about some key concepts, like in reconnaissance, we covered about your Google dorking, scanning, your Nmap, gaining the access, your Metasploit framework, your exploit DB, maintaining the access Trojan, and covering the tracks we covered was your tools like your audit poll, like your ClearEV tools. So now in today, what we are going to do, we are going to cover some key concepts from standalone modules, that is your sniffing, social engineering, web application attacks, cloud, cryptography, and some final question drills we will be covering in today's session. So we will be starting with our very first concept and we'll be discussing some questions around it. That is your sniffing. So, what is a sniffing? So, back in the childhood days, I remember like we were using telephones to communicate from one particular point to another. So, what used to happen, like if you see here, we were having telephone poles, like let us say A, B, and C. Now, if there was any particular problem, so you would have seen that there would have been an engineer, technical one, and he would visit a telephone pole. He will climb on this particular pole, and there he will connect a device. He will fix the issue. And but with this device also, let us say there is A and C, and they are communicating with one another. So here, this particular technician using that device, he can actually listen. He can just not able to find the issue, what is happening wrong there, but he could also actually listen to the conversation that is happening between A and C. So here, what this particular technician was doing is known as your sniffing. So packet sniffing is a process of monitoring and capturing all data packets passing through a given network using software applications or hardware devices. So how does the sniffing works? Here, sniffing works in two ways, which we will discuss. That is your passive sniffing and active sniffing. So in passive sniffing, it is generally done through a hub wherein the traffic is sent to all the ports. So here we are not injecting any packet into the particular network. Here we are passively, without interacting with any host, just listening to the traffic passively. On the other hand, when I say active sniffing is done on switch based network, guys. So here the attacker will be injecting some packets into the network. Here, it will not be just passively listening to the traffic that is happening between the host and the network. He'll be actually injecting some packets, and with that, it is known as your active sniffing. And there are multiple techniques of active sniffing, that is your MAC flooding, DNS poisoning, ARP poisoning, like that. So here, before we jump into passive and active, let us understand what is actually hub sniffing and what is actually switch. So what is the difference between hub and switch? Let us understand that. So here, when I say hub, okay, so let us say this is a host and this is the particular receiver here. So here F wants to send to B. Now, hub is a not intelligent device, non-intelligent device. So what hub does, if I'm sending any data packet, this sender is sending any data packet, let us say D1, the hub will broadcast it to all the hosts in the network. So assuming that here the sender wants to send it to B, yes, B will receive this data packet D1, but so will every other host in the network. That is your hub, a non-intelligent device. So what if this A here, it is an attacker? can attacker listen? Can attacker passively sniff all the traffic that is being sent from F to B? Yes, it can. So how the attacker will do it? Attacker will turn its NIC, that is your NIC card is there, it will turn it from the manage mode to the promiscuous mode. So it uses a tool that is your Wireshark. So guys, let me show you an example of this. So let me assume I am an attacker, and as an attacker, I am running this tool Wireshark. So what is a Wireshark tool? Wireshark tool is a packet capturer tool with which we can capture and analyze the packets. With the same Wireshark tool also, we can sniff the packet as well. So here, let us say I'm running this Wireshark and there is a victim here. So victim went to this site, that is testfire.net, and the victim is trying to log in into this website. So let us say victim is sending the credentials here, that is admin and admin. Now, since we are running the Wireshark tool as a Kali, as a attacker, what can happen? What if the credentials we are sending to this testfire servers there? What if in transit there is no encryption? So how can we know that there is no encryption? This is an HTTP site. As you can see, the connection is not secure at all. So here, once I will send it, I'll click on login. Yes, I am able to log in into this, but if the attacker was there in the same network and attacker was using this tool, the Wireshark tool, and if we were not encrypting our credentials when we were sending it in the network, what can happen? Attacker using the Wireshark tool will be able to sniff that credentials. So if I see here HTTP filter, I can see here that this is the request here, login request, and here I can see the credentials that the victim sent. That is your admin and admin. So this is how guys your passive sniffing works. Usually passive sniffing, whenever the hub was there, what we did was we used our Wireshark tool. We convert the using the Wireshark tool, we convert our NIC to the promiscuous mode, and then once in the promiscuous mode, what can happen is now any traffic that is sent from F to B or F to, let us say, testfire.net server, as an attacker, I can sniff the traffic. So that is your passive sniffing, guys. On the other hand, when I say active sniffing is done on switch based network. So how this will work? Let me show you here. First of all, let us see how the switch is different from the hub. So here, let us say this is the F, our sender here, and this is the receiver C here. Now, if I'm sending the data D1, what will happen in this case is switch is an intelligent device. Switch knows on which particular port I have to send this particular data. So if all these ports are there like P1, P2, P3 port like this, switch knows, okay, the data that I have to send is to this port P3, and because there is that particular receiver there. So in this case, the traffic here is not broadcasted to all the other hosts in the network. That is your switch we are having. So how the switch knows that on which particular host, on which particular port that is there, that particular host is there on that port, is by maintaining a CAM table. So what is this CAM table and how does it fills up? Let me show it to you. How does this CAM table works? So let us assume that there is this A, and A wants to send some data to B. So what happens that A needs the IP address and the MAC address of that particular B in order to send the data. So what the A will do, A will first of all perform an ARP request. So what does the ARP request do? ARP is for resolving your IP to the MAC address. So in this case, once the ARP broadcast is done, ARP request will go to all the hosts in the network. It will go to B and C, and only the B here will respond that, okay, this is my MAC address and I'm sending it to you. So this is the ARP reply that the B will send. So only for which the ARP request is for, that is it's for B, only that particular host will respond. Let all the hosts that will be receiving this ARP request, they will be discarding that particular packet. So only B will respond that this is the MAC address of me. And here this is a switch. Since switch being an intelligent device and it is having a CAM table, switch will see that this ARP reply is coming from which particular port. So here it knows that, okay, the ARP reply is coming from this port second. So now it knows, the switch knows that this B device here, the MAC address of B is linked with this port second here. And this is how the CAM table is filled. So now the A also knows the IP address, and now it knows that the B is on B's MAC address. It also know now. So what the A will do, A will now send the traffic to this MAC address. Now switch being an intelligent device, it will look into this CAM table. It will see that B is situated on port second, and all the traffic will only go through this port second. So this is when what I mean by your switch being an intelligent device. If F wants to send to C, only the C will be receiving the particular traffic and no other host in the network. So guys, now if I say that there is another host that is an attacker, how can the attacker now sniff the traffic? Once, because the traffic is not going to that particular attacker's host system. So now what he will do, the attacker will perform active sniffing, guys, in which the attacker will inject some packet into the network to make this switch malfunctioning. So how the attacker will achieve this is by using a popular technique, that is your MAC flooding. So before we understand what this MAC flooding is, let me tell you what will happen if this CAM table gets full. So as we discussed here in this case, in the very first case, this is the CAM table which is having A, B and C MAC and the port addresses. Now in this case, let us say the attacker is there and attacker injects some packets into the CAM table and it injects it with fake MAC addresses and port number. So as you can see in this case, what will happen if the CAM table is full of fake MAC address and port number, guys? What will happen? Let us say instead of A, B and C, attacker just filled it with fake Y, Z, C like that, fake MAC addresses and port numbers. Now if A wants to communicate with B, A will send the traffic to B. Here switch will look into the CAM table. Now can the switch find out where B is? It cannot find out B in this particular CAM table. Why? Because this CAM table is full. It is filled by the fake MAC and port numbers. And he is not able to find the B. So what the switch will do, switch will reset its learning mode and it will broadcast on every port like a hub. So a key pointer here that you have to remember, guys, when the CAM table is full by attacker injecting some fake MAC address and port numbers, the switch start behaving as a hub. And we know hub is not an intelligent device. It broadcasts the traffic to all the ports, to B, to C, it will be broadcasting it. And if there is an attacker also, attacker will also get the network, also get the traffic. And here attacker will be able to sniff the particular traffic now. So this is how attacker fills the CAM table by this MAC flooding active sniffing attack, guys. So what happens in this? MAC flooding involves flooding the CAM table with fake MAC addresses and IP pairs until it is full. So once it gets full by fake MAC addresses, if A wants to communicate with B, switch cannot find B in this CAM table. And since it cannot find it, it will broadcast, it will reset its learning mode to hub, it will broadcast to all the hosts in the network. So the tool that we use to perform MAC flooding, the attackers that use it, is your MAC off tool, guys. So let me show it to you with an example how we can perform it. Here, what the attacker will do. Attacker will use this MAC off tool. So let me see the help option and I can set the interface here. So what is my wired interface? That is 𝐂𝐞. This is the 𝐂𝐞 interface I'm having. So what I will do, I will use this MAC-off tool on this interface 𝐂𝐞 and I will send the fake pairs, MAC addresses and fake pairs to that CAM table. I will fill it. So let us say I'm going to send, let us say 50. So you can see 50 fake MAC addresses will be filled in the CAM table. Now I can continue this MAC off without mentioning -n and it will start filling continuously the fake MAC addresses and the port number on this CAM table until the whole CAM table gets filled with fake MAC pairs there. So this is how the attacker performs your MAC flooding. So this is a key concept that is in this particular module and I have seen multiple times questions coming from this. So let us see some MCQs based upon this that has came previously. A pentester member has gained access to a network. He configures his NIC for the promiscuous mode and sets up a sniffer, plugging his laptop directly into the hub. He watches traffic as it arrives at the system, looking for specific information to possibly use later. Remember, guys, that first of all, we know that there are only two types of sniffing, that is active sniffing and passive sniffing. So you can cut D and B. Now, if you look into this, as it mentions hub, as it mentions promiscuous mode. So here you can see that in passive sniffing, the attacker directly sniffs through the hub. And how it does it? It uses Wireshark, which converts the NIC to the promiscuous mode, and then it sniffs it. So the correct answer here, everyone is yes, everyone is correct here. That is your C. That is your passive sniffing, guys. Then one another question came in the CEH. Which type of attack attempts to overflow the CAM table in the Ethernet switch? MAC flooding, DNS cache flooding, DDoS attack, evil twin attack. That is MAC flooding. So if you remember, the tool that we used was your MAC off tool. So it is very, very important tool. Also in the practical, also it can come in the question as well, like perform this MAC flooding attack on this victim machine there. So just like this in this sniffing module, we are having this particular one. So this is very, very important from the exam perspective. Just like this, DHCP attacks, DNS poisoning, and ARP poisoning attack. So these are also key concepts that you have to learn in this particular module. Many questions will come from these four topics. So this was the key concept for our sniffing module. Then let's move to our next one, that is your social engineering. So this is the ninth module in your CEH. And what is this social engineering? Social engineering is a term that is used to describe the manipulation of individuals or groups into divulging confidential information, performing actions, or making decisions that may compromise the security. So unlike your traditional hacking methods that exploit vulnerabilities in software and hardware systems, Social engineering exploit human psychology and behavior. So unlike your traditional methods, like there was an attacker used to be proficient in technical tools, but in social engineering, not only has to be proficient in technical tools, but also in the soft skills. Because here it has to also exploit the human psychology and behavior. And that is why the attacker needs a combo of both technical and soft skill. That is why performing social engineering is an art. So how the attacker can exploit the human tendencies? Because attacker knows the most vulnerable link in any system security is your human link. Human is the weakest link in any information system security there. So what attacker can do, attacker can take advantage of this. For example, using a human behavior like authority. So for example, guys, you all are working in the organization. Now let us say on one particular day, you get a phone call from your executive, from a high level executive, which is demanding from you an immediate access to the confidential files for some urgent matter, let us say that. So as you are just let us say a standard employee in the company, you will be giving that, or you'll be complying with that request without questioning him, because he is pretending to be a high executive. Here the attacker is there, he's pretending to be a high executive. So you might provide him that confidential file there. And that is how it is, this attacker is taking advantage of this human behavior, that is the authority. Another one we could have is scarcity. Let us say you got an email which says that only these are the few products that is remaining, like Amazon email you got which says this particular product is going to expire, or it is going to be out of sale. So here is the link, click on this particular link so that you can buy that product. And if you really needed that product, what you will do is you will click on that particular link. That is the scarcity behavior, human behavior, that it is exploiting, the attacker is exploiting. So just like this, we are having so many social engineering techniques. The first technique we will discuss here is your typo squatting. So when I say typo squatting, let us say this is the Google here, and this is a legitimate website. Now what the particular attacker will do, attacker will register this domain name which is very similar to this domain name, so that it could trick the particular users here into visiting these domain names. So here it will be making some little changes, like instead of double O, it wrote here 00, then Google. So here it will be registering very similar to this to this particular domain name there. That is your typo squatting. So if a victim falls victim to this, clicks, does not see that it is not a legitimate google.com, and here it tries to log in, like it tries to uh, write his credentials of the Google here, username and password. Here the attacker will be able to get the credentials of the victim. That is your typo squatting technique. Then we are having is water hole attack. So let us say, let me take any one of you. Let us say this is your Rahul. Another one we are having is Agnihotram, and another one we are having is Rocks. So these are the three individuals, and I am the attacker here. Now what I want to do is I want to attack on these three individuals. So one thing I can do is I can individually target them, or I can perform reconnaissance on them and I can get to know what is their preference. So let us say all three of you visit a site that is news.something.com. So what I will do, instead of targeting you individually, I now know that okay, all three of you visit this site frequently. So I will target this particular site. I will implant some kind of a malicious code into this particular site. I now know that all three of you will visit this site. Once you visit this site, that malicious code will be also evading your system, and that is how the water hole attack is there. So here attacker, if it wants to target a like-minded group, it will first of all know what is the preference. And instead of targeting the whole like-minded group individually, he will target the particular preference of those like-minded groups. So that will be very easy for the hacker. Instead of individually target each and every one of them. So that is your watering hole attack. Another one we are having is dumpster diving. So guys, in dumpster diving, what we do, like this is the particular attacker there. Now you would have seen that in the organizations that there are many shredders that are there. Like whenever you want to shred any paper document which might be containing some sensitive information like that, you first shred it and then you throw it into the dumps. What if you do not do that? You do not do shredding of the sensitive documents. Attacker can look into these dumps and he will be able to find out the passwords, the access codes, organization charts, network diagrams, credit card receipts like that from these dumps. And that is your dumpster diving. Here the attacker is diving into these dumps and getting the information of the organization. Then one another key concept that is very important from CH exams it can come, that is your piggybacking and tailgating. So if you see on this left hand side, this is your piggybacking, and on the right hand side, it is your tailgating, guys. So what happens in piggybacking? Let us say this is an unauthorized individual and this is an authorized individual. So here, unauthorized individual is aware. It is aware that there is someone behind him. And here the authorized, let me just once again create a scenario. Let us say this is an authorized individual, as I can see that it is having a smart card. Okay. So this is an authorized individual and this one is an unauthorized individual. Now here, the authorized individual here, it knows that there is an unauthorized individual with him and this unauthorized individual is telling him actually, or it is performing a social engineering technique. Actually today, I forgot my smart card. Can you provide me the access with you to that particular door, through this particular door? That is your piggybacking. And what if this authorized individual gets social engineered? He buys the story of this particular unauthorized individual and provides an access with him, like you can see in this case. That is your social engineering or piggybacking attack. So here this unauthorized individual spun up a story, a fake story, and it tricks that particular authorized individual to get the access to the secure door. That is known as your piggyback. On the other hand, when I say this tailgating, as you can see in this next figure, this is the authorized individual. This is the unauthorized individual. Here in this case, authorized individual is not aware of the surroundings. He is not aware of the surrounding that someone is closely following him from behind and he's not paying attention to that. And here the unauthorized individual tailgates him and gets access to this secure region. That is your tailgating, guys. So there is a very little difference between these two figures. Here the authorized individual, here the unauthorized individual spins up a story and then get access. Here he's tailgating him because here the authorized individual is not paying any attention. That is tailgating. So to prevent this tailgating, we are having in the organizations, or you will see these tools, these particular machines are there. That is your turnstile. So even though it looks a little fancy word, if I show you here, guys, in your metro station, have you seen this type of security solutions that is embedded there? you would have seen how this is preventing the tailgating. If the authorized individual has a smart card, it will put on this or a token it is having. This will lift up or this will lift down, let us say that. Then he will go through, and as soon as he will go through, it will once again lift up so that no unauthorized individual can tailgate him. Behind him, he is able to get access to this particular region. That is your turnstile. So you would have seen this in the organization as well. So that is piggybacking and tailgating. Now we will discuss about is your phishing attack. So here, what phishing refers to, it is an attempt to steal some sensitive information, typically in form of usernames, passwords, credit card numbers, bank account information, or other important data in order to utilize or sell the stolen information. That is your phishing. So here, what you do is you can perform phishing using many tools. Like we are having is your Zfisher tool. You can perform it using that. 69 Fisher is there, with which you can create a fake or a phishing link, and this link could contain a clone of any particular like login page of Instagram.com or Facebook.com, like that. So you can create a fake clone using this tool, that is Zfisher there. So let me show you how you can create a Zfisher, how you can create a phishing link using this tool. So this is the tool that I am having, that is a Zfisher. Now using this particular tool, I can create any login page of, let us say, a fake login page of Instagram I want to create. So I want to create a fake login page of traditional login page of Instagram. Here I'm selecting Cloudflare as a service. I do not need a custom port right now. I do not need to mask the URL right now. So here the Zfisher tool will work. And let me show you that what is the login page of Instagram.com, how it is looking. So here, this is the login page, the real login page of Instagram.com. Now here my Zfisher tool is working and it gave me this link. So this is a fake link. This is a phishing link I'm having. So let me just paste it in here in the browser. So let me once again copy and paste it in here. Okay, right now it is saying that it is not able to create that particular website there, that phishing link there. So let me do one thing. Let me run this tool once again. Until then, let us look into the theory part. Because many times this is an open source tool we are having. So sometimes it works, sometimes it gives error. So let it run. Until then, let us discuss some theory. So first is your phishing. So we are having different types of phishing that is there. So if the phishing that is done through your voice call, let us say if someone is impersonating as a bank and calling you, like let us, it is saying that your account has been logged or this much your account has been compromised. Quickly give me your account's details so that we can block your account. So that is the phishing. Phishing done through your voice call. Smishing is phishing done through your SMSs. So just like in the emails, if you're getting the phishing link, if you're getting the phishing link in your SMSs, that is known as your smishing. So these are the two that we are having. Now let me just quickly copy and paste it in here to see if this open source tool is working now. Okay, so now our phishing link is working, and you will see that this is a fake link, and you can see it is how closely it is resembling the particular Instagram login page. So what I'm going to do, guys, I'm going to copy and paste it in the chat box. Now go to this site and let me give you a reminder that this is a fake link. Here what you will do, you will write any random thing. Definitely do not write the real username and password of your Instagram, guys, and click on login. So using this fake link, I can get to know what you would have typed in that particular username and the password field. So let me show it to you here. In this case, if I write here my name, Ashish, and Ashish here, and click on login, here I can see the Z Fisher was able to steal the credentials that I've written in that fake link. That is your Ashish as a username and password here as Ashish. So this is how powerful this Z Fisher tool is, with which we can create fake links. So based upon this, let us see some MCQ. Which social engineering attack involves compromising a website commonly visited by the target to exploit them? Water holing, typo squatting, phishing, pretexting. Here, guys, remember the example that I talked about. If I'm having three users, user 1, user 2, and user 3, I know all these three users visit a common site. So now, instead of targeting these three users individually, I'm targeting this common site. What was the attack? Water holing, typo squatting, phishing, pretexting. It was, yes, correct. That is, it was your A. That is your water holing attack. Which social engineering attack involves an unauthorized individual sneaking into the secure area by closely following an authorized individual without their knowledge? Tailgating, piggybacking, phishing, dumpster diving. A is the correct answer. So many times question can come with piggybacking and tailgating. There is a slight difference between them, and MCQ could have both of these options, so do not get confused there. So this is the topic that were discussing in your social engineering. Now let's move to another attack that is in the web application. That is your injection attack. So in this also many questions can come from this key concept. So we are having some web application attacks for your layer 7 application layer. And one such attack we're having that is listed in your OWASP top 10. So OWASP top 10 here, it gives you the top 10 vulnerabilities that is existing in your web applications. So here, injection is one such category that is listed in the top 10 of OWASP. And in this case, the injection is an attacker's attempt to send data to an application in a way that will change the meaning of commands being sent to an interpreter. So what I mean by that, let us say this is an ID parameter, and this is the particular field here, input field for this ID parameter. Now, what if this ID parameter is not having input validation? It is not having input sanitization. What can happen? Attacker can simply just embed a script into this particular ID parameter. And once this particular database interpret that script, it loads that script. Then if the script is for, let us say, stealing the sensitive user data, then attacker will be able to do this. Why? Because attacker was able to inject this malicious script into this ID parameter. That is our injection attack. And we are having different types of injection attacks, like we are having here cross-site scripting, we are having is your SQL injection. So one such attack we'll be discussing in our today's session, that is your cross-site scripting, that is your XSS. So remember guys, yesterday we performed cross-site scripting in your cyber kill chain, the attack that we performed yesterday. So here the XSS here, according to your CH, we are having it is of two types. That is your reflected and your stored XSS. So let me show you here the very first one. That is your reflected XSS, guys. Now in this reflected XSS, what the attacker can do is, attacker can construct a malicious link. Then in that particular link, like I just now constructed this fake phishing link that I was having. And just like this, it can construct a fake link. And in this fake link, there would be some kind of a script that would be there, an XSS script that would be there in this fake link. It will, in the URL, it will be there, it will send it to the user. And as soon as the victim will click upon that fake link, the victim system will be requesting the page to that legitimate server, and then the legitimate server will embed the page with the malicious script. And once the browser of the victim loads that page with the malicious script, will also run by the browser, and the script will be running. So if the script is for stealing the session cookies of that particular victim system for a particular website, that will be happening using this script. So that is a reflected XSS. So let me show you why it is termed as reflected. Let us say this is a site I'm having, that is testphp Now in this case, the attacker, anything that I'm typing here, you can see it is getting directly reflected. That is why it is reflected XSS attack. So if I type here my name, it is getting directly reflected here. Now what I can do is I can embed a script in this search parameter. And what if the victim executes this script? An alert box will be displayed. So right now the script that I'm tapping was of show me the alert box which displays 1. So that is how the reflective XSS works. Now let us say, assuming there is the victim and victim is logged in into this particular website. So here I'm using the particular username and password as test and username as test. Here victim being logged in, what I mean by that is victim would be having the cookies for this test PHP site there. And this is the cookie login cookie for this particular victim for this particular victim account. Now this is very important. What if the attacker is able to steal this session cookie, this test percentage to have test? What can happen is attacker can impersonate this particular victim. So this is how crucial your cookie is. Now attacker, what the attacker will do? Attacker will create a fake link and it will embed it in the email. And let us assume the victim clicks upon this link and loads this script into this particular website. So the script that the victim loads here is this script document dot cookie, and let me give an alert box here. Alert box for document dot cookie. And as soon as the victim will load the script, guys, can you see? Here the alert box is displayed with the same cookies that I was mentioning. So this was just for the educational purpose. What can actually happen in real life? Attacker will be having not an alert box script. It would be having a malicious script which will be transferring or stealing the cookie from the victim's browser where the cookies are kept to the attacker system. And that is how it has been done using your reflected accesses. So what I can do here in this case, how can I mitigate this? So to mitigate this, as I can see here, it is getting directly reflected here. The alert box is showing me this test percentage to have test. Here there is one parameter that is HTTP only. Secure parameter is also there, same site parameter is also there. So these are some parameters which can mitigate our accesses. How? So if I put this to true, so what I mean by that is our cookies cannot be stolen by any client-side script. The cookies can only be transferred via HTTP. That is your HTTP only. So now once again, if I run this script here, so this is the script that I'm running once again, but right now this HTTP only is turned on. So now what will happen if the attacker tries to steal the cookie? The client-side script will not work and our cookies are not displayed. Why? Because this HTTP only parameter is turned on. It is true. This is how we can mitigate our reflective cross-site scripting, guys. Now what we will do, we will be looking into another one, that is your stored cross-site scripting. So what is this in stored cross-site scripting? Here we are storing our malicious script into a particular database server. That is my stored accesses. So as you can see in Instagram and all these things, you are having the post, and in the post below, you will be having comment section where you can embed or you can write your own comments on that particular post. Now, what you can do is here, let us assume that the attacker is there and attacker wrote a script, a malicious script on that comment in the comment section. What will happen here, as soon as you will load this malicious script and you will go to this particular post, that malicious script that was in your comment that was stored in the database will also get loaded. And as soon as it will get loaded, you will be seeing the script getting executed by your web browser. You'll be seeing a dialog box, something like that, which was stored in the database server. So let me show it to you with an example. Let us say this is the blog I'm having, and in this case, I'm having these posts, post 1, post 2, post 3, like that. So guys, here, what I'm going to do right now, I'm an attacker. And here, being an attacker, I'm going to click on this first post, that is this post here. Now, in this case, I can see the comment section is there. Now, what if the input validation and sanitization is not done in this comment section? I can store a malicious script in the database server. So how will I do that? Let me store a script here. So what the script will do, anyone who will be clicking on this post, it will be redirecting you to another URL. So let us say it is going to redirect you to infosectrain.com. So this is the script I have written here. As soon as anyone click on this post, he will be getting redirected to this site, that is infosectrain.com. So let me write the name here as an attacker. Let me write something gibberish here. So this is the script I am storing in the database server. So I'm going to click on post comment. Now this is the home section. Why you were once you were visiting this post you got redirected, because the script also got loaded which was stored on the database server. As soon as I click on this post, I will get to this post and the script will load from the comment section, and I got redirected to infosectrain.com. So this is how your stored access works. And in this case, your reflective accesses and your stored accesses, I've seen many times questions coming in the exam. So one such question that can come based upon this is, you have discovered someone is posting strange images without comments on your forum. You decided to check it out and discover the code is hidden behind those images. So this is the script that is posted in the comment section. That is the stored accesses that is happening here. What does this script is doing? A, B, C or D. This script might be doing here. Here, let me give you a keyword. Here, what the script will do, script will submit the cookie which is stored on your web browser. As you can see, document.cookie. It is going to steal, this script is going to steal the cookie that is stored on your web browser, and it is going to give that cookie or transfer that cookie from the victim system to the attacker system. So guys, if you read this D here, this D particular this one here, you can see this PHP file silently executes the code, grabs the user session cookie, that is the document.cookie as I showed you in the very first example. It is grabbing that cookie and that session ID that is there, and it is transferring that cookie to the attacker system. This is how the attacker is stealing the cookie. So D is the correct answer. A security administrator sets the HTTP only flag in the cookies. Which of the following is the most likely attack the administrator is trying to mitigate against, guys? I want every one of you to answer this one. CSRF, XSS, buffer overflow, SQL injection. The parameter, once it is set to true, it is mitigating against which vulnerability in this case? A, B, C or D? Do you guys remember in this the HTTP only flag that we set up here as true? Once the flag was set up to true, the client side script was not working with which the cookies can be stolen. So that client side script is your cross-site scripting, the scripts that we are having. So here we are mitigating by setting this to true with for this vulnerability, that is XSS, that is your cross-site scripting. So B is the correct answer. So in this web application part, this is the correct answer, that is cross-site scripting. No issues, Arim, we are all here for the learning only. So the key takeaway from this web application injection series is your cross-site scripting. I have seen multiple questions coming from this. Then similar to this, we are having SQL injection as well. So lots and lots of questions come from this. Your in-band SQL injection, blind SQL injection, out-of-band SQL injection, like that. So in this, these two are topics that you will be covering for your CEH exam. Then let us move to another one, another module, that is your cloud computing. So in cloud computing, we are going to discuss two key modules, two key concepts with which many questions come. At least 2 to 3 questions you can expect from these two key concepts. So first is your cloud service models, and another one we are having is your cloud deployment models. So what is this cloud service model? Now let me show you here. This is my AWS account, and in this case I'm going to show you the cloud service models here. So we are having three types of cloud services. That is, the first one we are having is your IaaS, infrastructure as a service, then platform as a service, and software as a service. So these are the three main services we are having. So this cloud service model is about how the cloud computing services are delivered to you as a user. So let me give a very layman example first. Let us say this is me here, and this is my hometown. So in my hometown, I'm having a house. So in my house, I have to manage everything. Like I have to manage my furnitures, I have to manage the AC, I have to manage all the equipments I'm having in the house. Then what I did, I went to a city. In the city, I rented an empty flat. Okay. So in the empty flat, the owner of the house, which is the cloud here, the cloud service provider is the owner. So here the owner of the house, he gave me just an empty flat. Nothing was there, just the infrastructure he gave me. And in this infrastructure, what I have to do is I have to buy the furnitures, I have to buy the ACs, everything I have to buy. That is infrastructure as a service. Here, cloud service provider will just give me an infrastructure. Rest all the things I have to maintain, like OS operating system, the middleware, the data, everything. That is my infrastructure as a service. Then I'm having is your platform as a service. So in platform as a service, let us say instead of renting an empty flat, I went for furnished flat. So you guys might have heard this term furnished flat. In this, you get all the furnitures. Owner is providing you the AC also in this. And in this furnished flat, you just have to take care of your own equipments, of your own applications there. Your laptops or clothes like this. So that is your furnished flat. So in this case, let us say that if the AC gets broken down, who will be fixing that AC in furnished flat? It will be the owner. But in the case of infrastructure as a service, if the AC got broken down, who would be repairing that AC? Here, the AC will be repaired by the renter there, by me. I will be repairing it because I have bought that AC, and if something happens to that, I will repair it. And the last is we are having a software as a service. So let us say I did not went for empty flat, I did not went for furnished flat. I simply went to the city and I went to a hotel. So in hotel, all the things are managed by the hotel. I do not have to maintain anything there. That is my software as a service. Here, nothing is managed by the cloud service provider. So one such cloud service provider I'm having is your AWS. Here, AWS can provide us various cloud computing services, like it can provide us virtual servers, it can provide us storages like these. So one example of your infrastructure as service is your EC2 account or EC2 server. So here, if I show you the EC2 server with which you can deploy virtual servers in the cloud. So if I launch an instance here I can set everything. I can set what is the operating system. I can set the storage. I can set the network configuration here. So if you see here, I'm setting the volume to be 8 GB. I'm setting the operating system to be Linux. I'm setting the processor to be T2.micro, and I'm deploying one virtual server. So here, this is the infrastructure as a service that I'm having. Here all the things is controlled, more like these are the things that are managed by me. And here the particular EC2, the AWS, it is providing me just the storage, the networking part, virtualization part, that is rest operating system, middleware, I am configuring it, I am managing that. So EC2 is an example of infrastructure as a service. Then we are having platform as a service. So if the EC2 is used by your like network administrators, like these uses this EC2 service, platform as a service is used by your web developers, which do not want to manage anything. They are only interested in uploading their code. So one such service that is there in the AWS, that is your elastic beanstalk. So if I show you, this is the elastic beanstalk I'm having. Here in this case, you can create your application. You can just write your name of the application, let us say web app. And then here you can just choose the platform for the web application, like it is on based on Node.js. And then you can just upload your code. You can upload your code here and that's it. Here you are not managing anything. Like in EC2 instances, you are managing, you are configuring your operating system, your processor. You are not here doing anything like this. You are just uploading your code, and rest all the thing is managed by the cloud service provider. That is your platform as a service. And last is I'm having is software as a service, and this is for your end users. So let me show you here. When I say the end users, here nothing is managed by the end users. Like for example, all of you are using your Google Drive. Are you managing anything on this Google Drive? No, we are the end users. We are having Netflix. We are having Gmail account. These are all software as a service, and all of these are not managed by us, but all the services are running on the subscription based model. So when I say this word subscription based model, what I mean by that is, like if you're using Netflix, so you would have seen that there are different subscription models, 200 rupees, 400 rupees, 800 rupees, like that. For Google Drive, if you are having 5 GB or 15 GB, it's provided for free. Then if you want to have more storage, then there is a subscription for that 50 GB. Then if you want more, then it could have another one. So all that thing that you have to worry about is your cost, and everything is managed by the vendor. So all the data that you are keeping on a Google Drive, it is managed by the vendor. Nothing you have to worry on your end. That is your software as a service. So based upon these three, I have seen multiple times question coming up. So let us see the MCQ. Your company has decided to purchase a subscription to a cloud hosted solution. After purchasing the solution, the only administrative task of your employee will be management of the user accounts. The provider will cover all the hardware, operating system, software administration, including patching and monitoring. So guys, tell me which of the following is this type of solution? Is it software as a service, infrastructure as a service, customer as a service, platform as a service? Is it software as a service, infrastructure as a service, container as a service, or platform as a service? Guys, look into this here, where you can see here, let me just erase it, which is managed by the vendor. By the vendor. So when I say the vendor, here you can see in IAS, only this thing is managed by the CSP. Then pass up until this point is managed. And in your software as a service, all the things are managed by the CSP, by the vendor. Here, you are not managing anything. You are just like the provider here, the CSP cloud service provider. It is covering everything. The hardware, operating system, software administration, everything is covered by them. You are just using that particular software. So you are the end user here, where you are not managing anything, and this is why A is the correct answer, that is software as a service. Then in which of the following cloud service models do you take full responsibility for the maintenance of cloud based resources? IaaS, PaaS, SaaS, BaaS. Full responsibility meaning that you are managing most of the things. Many things you are managing on that particular server, let us say that. Rocks in C, as I discussed in software as a service, here nothing is managed by you. So what is the opposite of C? Where everything is managed, like not everything, but most of the things is managed by you. As you can see in this particular one, here you can see out of these three, IaaS, PaaS, and SaaS, which is the one service where where many of the things is managed by you. That is your infrastructure as a service. So here, yes, correct, Agniotram and Rahim. A once again is the correct answer. That is IaaS, infrastructure as a service. So with this key concept here you are managing everything. In PaaS, you are just uploading your application, and in software, nothing is managed by you. So these are the three that you have to remember for your CH exam. Then another key concept that we will learn is your cloud deployment model. So here in this case, we are having 5 types of cloud deployment models. That is your public cloud, private cloud, hybrid cloud, community cloud, and multi-cloud. So first is your public cloud. So what is this public cloud? In public cloud, we are having services which is available to everyone on the internet, which is available to public on the internet. That is why it is your public. So the public cloud, it works on this concept, that is multi-tenant model. So what is this multi-tenant model? Here, let us say you guys are having Google Drive account. Rox is there, Agnihotram is there, Ankush is there, and Rahul is there. Let us say that. So you're having Google Drive accounts, and what does this multi-tenant means? It means that you are having all 4 of you are sharing the same resources. That is your multi-tenant model. That is your public cloud. Different users are using the same resources. So if you are having Google Drive account, you are having a same hard disk. Let us say it is a 100 GB hard disk. So 25 GB is allocated to ROX, 25 to another one, like that. But the same, all of you 4 individuals are using the same hard disk. That is your public cloud. Then we are having is your private cloud. So private cloud here, in this case, the infrastructure that you'll be deploying, it is only available to just one particular person or one particular organization. The resources are only available to just one individual or organization. That is a private cloud. By the name itself, you can see it is private in nature. Then we are having is hybrid cloud. So in the hybrid cloud, we are having is the combination of both public and your private cloud. So many times the organizations today, they are using both public and private cloud here. They're not just dependent on one cloud. So what they do, like if there's a company here, it is having some sensitive data. So this sensitive data they will store in the private cloud. On the other hand, if they're having some other data, like they're also having an e-commerce site, which is a public facing application, so they will be having this e-commerce site, they will be deploying it in the public cloud. That is how the hybrid cloud is born, combination of public and private cloud. Then fourth one we are having is community cloud. So in your community cloud, let us assume that in this case, there are four organizations which are with the similar interest, like they're belonging to the same community or sector. Let us say, let me take a banking sector. So I'm having HDFC Bank, SBI Bank, Axis Bank, Yes Bank. So they all belong to the same community, they all belong to the same financial sector. And what they will do, they all will come together and they will form a community cloud. So why they will be forming a community cloud to use? Because they have to meet up with the regulations. They have to meet up with some regulatory requirement. They are having some common interest. This is why they all the organization with the same interest, they come together to form a community cloud. And the last one we are having is multi cloud. So here what I do, like I am having this AWS, that is your cloud service provider. As you can see here, this is the AWS account I'm having. Now just like this, there are different other providers as well, like we are having is your GCP by Google, we are having is your Azure by your Microsoft. So when I say this multi-cloud term, we are not dependent on just one CSP. We are dependent on more than one CSP, so that if in one case, if we are not using the services of one services, we does not get logged in with just one particular CSP. We have other options as well. We are using other CSP as well. So that is your multi-clouds. We are not dependent on just one CSP, but dependent on multiple CSPs for cloud computing services. So with these five models in consideration, let us see some MCQs based upon this that have came previously in the exams. A company relies on private cloud solution for most of its internal cloud computing needs. After expanding into more online retailing, it relies on a portion of public cloud for external sales and e-commerce offerings. Which of the following best describe this cloud deployment, guys? Private, public, hybrid, community. As we can see, the company is using both private plus public. That will fall under your hybrid there. C is the correct answer. There are multiple cloud deployment options depending on how isolated customer resources are from those of other customers. Shared environments share the cost and allow each customer to enjoy lower operation expenses. One solution is for the customer to join to form a group with other users or organizations to share the cloud environment. So, which cloud deployment model is this? Private, community, public, hybrid. In this case, there are user 1, user 2, user 3, user 4, and they saw that they all are having a same interest, so they joined together and formed a group. So guys, tell me what is the correct answer for that? They are belonging to the same community, and this is why correct answer is B, guys. Yes, everyone is correct. That is the community cloud. So here the keyword was this: customer are joining to form a group. Your company plans to open a new division. You have been assigned to choose a cloud deployment model. The main requirements for the cloud deployment model are infrastructure operated solely for your organization with the ability to customize hardware, network, and storage characteristics. Which of the following solution will suit your organization, guys? A, B, C, or D? So the keyword was your solely. B is the correct answer. That is your private cloud. So only one particular organization can access the resources there. So B is the correct answer. So these are the questions that have came. And in your cloud computing, we are also having some attacks also, like cloud jacking attack is there, cloud hopping attack, cloud wrapping attacks are there. So some of the attacks are also there with which the questions can come. So you will read the cloud deployment models, you will read your cloud service models, and the last is some cloud attacks that you can read from this cloud computing, guys. Then next we are going for is your cryptography. So here, cryptography is the conversion of data into a scrambled code. So it is a conversion of data from plain text to the cipher text or non-gibberish text. That is your cryptography. So the objectives of cryptography here is that you can maintain your confidentiality pillar, authenticity pillar, non-repudiation, and integrity pillar. So with this confidentiality, with this cryptography, you can achieve your objectives by converting the plain text, a readable text, into the gibberish text. So there are two types of cryptography we are having with which the questions can come. That is a symmetric encryption and asymmetric encryption. So what is the symmetric encryption? What happens? Let us say this is A and this is B here. So A is sending this plain text. Now, before A and B start communicating, they will be using a backend channel. They will be sharing a secret key with one another. And this is the secret key with which they will be performing both. That is encryption and decryption. That is why it is known as symmetric encryption. So in this, A will encrypt, that is convert the plain text into the cipher text with the secret key, and then it will send it to the particular B. B will decrypt the cipher text back to the plain text with the same secret key. So in this case, if there is even an attacker that is there in the network, and let us say attacker is performing the sniffing, active or passive sniffing, attacker is performing it, still it will not be able to get this particular plain text here. Why? It will only be able to see this gibberish text because attacker will not be having the key. So let me display to you how the symmetric encryption works using this example here. So AES is an example of symmetric encryption. It is an algorithm. AES encryption algorithm is there. So you guys can perform it later on. Let us say this is the sender's end. Sender wants to send this message hello. Now it is using a simplest form of mode, that is ECP mode. Now here the secret key that is using here is AES encryption key. So this is the key that only two people in the world knows, that is the sender and the receiver, and they have shared it beforehand, before the communication took place. Now using this same secret key, the attacker will, not the attacker but the sender will encrypt this plain text to the cipher text. This is the cipher text that is non-gibberish in nature. Now what will happen? Receiver will get this cipher text. It will use the same mode of encryption and it will use the same secret key and it will decrypt it from the cipher text back to the plain text. That is your AES encryption. And that is how your symmetric encryption works. Now guys, let us move to your asymmetric encryption. So in your asymmetric encryption, instead of having one secret key, we are having two keys. So these two keys are your public key and your private key. So in your asymmetric encryption, we have public key. Any particular user will be having up two pair that is public key, and your private key. So what happens in this, let us say this is the sender. What the sender will do, and this is the receiver. So sender will have his public key and his private key, and receiver will have his public key and the private key. So now sender wants to send this particular plain text to the particular receiver. Sender will first encrypt this with the public key of the receiver, guys. So what happens in this? In this case, anything that is encrypted with the public key can be decrypted with the private key, and anything that is encrypted with the private key can be decrypted with the public key. So public key can be shared to anyone, but private key is private. It will never be shared to anyone. That is the public and private key. So in this case, the sender encrypts it with the public key of the receiver. Now it is in encrypted format. Once the receiver gets this was encrypted with the public key of the receiver. It can only be decrypted with the receiver's private key. So only receiver will be having that private key. No one in the world would be having other than him. And receiver will decrypt it using its private key and will be able to convert the cipher text back to the plain text with the help of private key. So let me show you once again one such algorithm that we can use for asymmetric encryption, that is your RSA. What I am doing is, let us say this is the receiver's public key and the private key. I have clicked on generate keys and this is public key and private key of the receivers. Now I as in sender, what I will do? I will be encrypting this text. Let us say I want to send this hello message. I will encrypt it with the public key of the receiver. So this is the message I want to send, that is hello. And this is the public key of the receiver. I'll copy it and paste it in here. So I will be encrypting it with the public key of the receiver. And this is the cipher text I got. Now guys, once the receiver receives this cipher text, only this private key, it is only known to the receiver. No one has access to this private key. Receiver has only this access to this key. Receiver will use this private key to convert the cipher text back to the plain text. That is your asymmetric encryption, where we are using two different keys, one for encryption, another one for decryption. So two types of cryptography is there, symmetric and asymmetric. Now let us see some hardware based encryptions as well that has happened. So in this one, we are using some specialized hardwares with which we can encrypt and protect our sensitive data. So one very important term that you have to remember for your exam, that is your TPM, Trusted Platform Module. So what it does, this is a cryptograph processor or a chip that is there, and this is present on your motherboard. So in your laptop, motherboard is there, and in the motherboard there is one crypto processor chip that is embedded on your motherboard, and it is an internal crypto processor. So what it does, this crypto processor, it stores your encryption keys, it performs cryptographic encryptions. All these things is performed by this TPM, Trusted Platform Module, guys. Then since this is an internal crypto processor, we are also having external storage, HSM, that is hardware security module. So this is an external security device which can also be used for crypto processing and storing your encryption keys, your encryption decryption keys there. It can be used for managing, generating and storing the cryptographic keys. That is HSM for your storing externally in devices. Like I have seen many times, there are people who are storing external devices. That is HSM, hardware security module. Then many times you have seen USB encryption is also done. So in this case, what we are doing is in the USB encryption, many times USB devices are also coming with which you can actually encrypt your data in the USB. So whenever you have to decrypt it, whenever you want to access your files in the USB drive, you have to first of all write the key. You have to first of all write the secret phrase. Only then you can get access to your data there. That is USB encryption. And last one important one that is there is your hard drive encryption. So what we do in hard drive encryption, we encrypt your hard drive using a technology that is your BitLocker. So let me show you here the BitLocker here. So here in this case, you can see that this BitLocker can help me in encrypting the hard disk. That is your BitLocker. It can encrypt the data on this device to help protect from offline unauthorized access. That is your BitLocker, guys. So using this BitLocker, what can happen? We can encrypt our hard disk. Now, what attacker can do? Let us say, let me take an example. Let us say I was in the bus and attacker stole my laptop. Now, after stealing the laptop, what the attacker can do? Attacker can simply open my laptop, take the hard disk, plug the hard disk into his laptop, and can access the content of the hard disk. Can he do that? He cannot do that if the BitLocker is there and I have turned it on, if I have encrypted my hard disk. So if the attacker attempts that, he will not be able to get access to the content that is in my hard disk, even if he removes the hard disk from my laptop and plugs it into in his own laptop there. Still, he will not be able to get access to the content. That is the hard drive encryption. Then one another that is there is your hashing, guys. So hashing, what happens in hashing? We are having a document, and what we do is we pass it through a hash function, like we're having MD5 hash, SHA-256 hash are there. And using this hash, what we do is we create a summary, a fixed digest for this particular document. A fixed value is there for that document. So if anyone alters this particular document, then what can happen? The hash value will change and I will get to know someone has tampered this document. That is your hashing. So let me show it to you with a practical. So let us say, guys, I'm having a file that is there. Confidential message password is 2345. That is the file I'm having. Now, what I will do, I will be creating a hash of this file. So I'm having different tools, like I'm having MD5 sum that is there, and I can write the file name. So guys, this is the hash of this particular file. Now let me do one thing. Let us say the attacker is there and attacker alters this file. So what attacker did, this was the file I'm having, and he altered something. Like he changed the password to, let us say, another one. He changed something, anything here in this file. Now, what will happen now if there is your data verification system that are kept here? What will happen in this case if I once again calculate the hash of this particular modified file now? The hash will come to be entirely different. As you can see, hash is completely different for this modified file. So with this, with hashing, we can protect our integrity pillar. That is how powerful this tool is, MD5 sum tool. Now guys, let me finish our webinar with the last practical that we missed yesterday. The result was not coming for that yesterday. That was your maintaining the access using ngRat tool. So before we discuss and load the lab, guys, tell me in this MCQ what should be the correct answer. Which of the following is a piece of hardware on the motherboard that generates encryption keys and only releases a part of key so that decrypting a disk on the new piece of hard drive is impossible? So where is your encryption keys kept on the particular piece of hardware which is internally embedded on your motherboard? What is the name of that cryptographic or crypto processor device, guys? GPU, UEFI, CPU, TPM. A device for which is internally embedded in your motherboard. What is the device that is the external device which is for storing cryptographic processors keys for processing? That is your HSM. So these are the two devices that you have to remember for your CEH exam. Sometimes question can come from this. So today we are going to perform one last practical, and it is a very interesting practical. So we missed it yesterday as it wasn't working. So let me see if it is working in today's session there. So let us assume this is the attacker's machine and this is the victim's machine. Now in this case, in maintaining the access, what I want to do is that I want to deploy a malware, a Trojan into this victim system. So here the tool that I'm using is ngRat, and using this ngRat tool, let me just run this tool here. So this is also a good tool we are having, ngRat tool. Now let me run this tool. And in this case, using this build option, I am going to build a particular Trojan. So this is the Trojan that I have built. Now let me, using some social engineering tools, like I can embed this Trojan in a phishing link. And let us assume that here the victim simply downloaded it from a fake email and he is going to double click on this Trojan. So as soon as the victim double clicks on this Trojan, guys, can you see that the particular system of the victim has been hacked? So this was not happening in the yesterday session, but today I'm made it in such a manner that this tool is working. So here, what I can do now, I have gotten I have compromised this victim system using this ngRat tool, and I have maintained the access. So here in this case, what if I want to, let us say, see what the victim is doing? I can see the remote desktop of this victim machine. Like, let us say the victim is opening the Google Chrome. I, as an attacker, can silently see that this victim here, it is opening the Google Chrome. Anything the victim will be performing, I can see it using this tool, ngRat tool. Then another one is I can also perform is key logging. So let us say victim here went to testfire.net, and here victim is going to write his credentials into this username and password. So the username and the password he's going to write here is admin and admin. And clicking on login, he's able to get access to that particular system, to this particular website. So now once he's able to get access to his website on on my attacker's system, I was having this key logging that was there. So I have compromised the system fully. So guys, let me just refresh this key logging option. Can you guys see admin and the admin that this victim wrote while signing into this website? I deployed this keylogger malware, and with this I was able to get to know that the admin was the username and the password that the victim wrote was your admin. So this is how you maintain the access, guys. And with this, we have successfully completed all the key concepts, all the MCQs that can come, all the practical sessions also that can come both in your theory and your practical CEH exam.